All right, so this is just over the last 2 days of content, so the beginning of Unit 4, and we are going to first solve radical equations. So remember that to solve a radical equation, first you have to isolate the radical. Then you're going to raise both sides to a power. In our case, we're going to just be raising to the second power, but remember if the radical had cube, we would go, raise to the third power. But we're just doing second power because I just made these square roots. Then after we do that to get rid of the radical, then we solve the equation that's left. So we get the radical by itself, and then at the end we get the variable by itself. So in this first one, if I want to get the radical by itself, what is on the side of the equation with the radical that's not underneath? The 8. And the 8 is being added, so to get rid of it, I need to subtract. And whatever I do there, I need to do there. Or maybe you think of moving it to the other side. So now I have the square root of x plus 7. 11 minus 8 is 3. Now I've isolated the radical. Now I'm ready to raise it to the power. Well, since this is just square root, the power is a 2. That 2 makes this go away. So we have x plus 7. And then what do we have on the other side? 9. So 3 squared, not 3 times 2, 3 to the second power. Then we're going to take the 7 away and get x is equal to 2. Also remember that we should be checking these answers because sometimes we might get extraneous results. And if I check this and I put a 2 back where the x is, I would have 8 plus 2 plus 7 is 9. And the square root of 9 is 3. 8 plus 3 does equal 11. It checks. So most of you got 2. You may not have checked, but in this case, it checks, so you're all right. In number 2, both sides start out with radicals. The nice thing about that is the radicals are isolated. There's not something under, or, like on the same side that's not under. So we are ready to raise to the power. And if I am raising both of them to the second power, but they were both under square roots, then all that's going to change is that we will no longer have the radicals or the roots. So if all of that and all of that, the numbers aren't actually changing, they are just out from under the radical. So we are now ready to solve the equation. So that's going to mean we've got to get the x's on the same side. And you might have combined some of these steps. Then I would add 8 and then divide by 3 to get x is 10. If we put 10 in, 10 minus 8 is 2, square root of 2. That would be messy, but don't get wigged out about that. On the other side, if I put 10 in, 2 times 10 is 20. 22 minus 20, also 2. The square root of 2 is the square root of 2. It's true. It does check. So it doesn't have to be a perfect square when you check it. As long as you have the same number under the radical on both sides, if it starts out with a radical on both sides. So that one also checks. That puts me on high alert that maybe number 3, we would have at least one extraneous because I'm probably going to give you at least one that's not going to check. I think most of you had a chance to, or maybe everyone, had a chance to work through those first problems And so you may have already asked questions to Razan or myself, so probably don't have a lot of questions there. In number 3, before you square both sides, we got to get the radical by itself. The 5x cannot stay there, so I'm going to subtract 5x on both sides. What next? Got to get rid of the radical. So to get rid of square root, I'm going to square. So on the left side, that just gets rid of the square root. On the right side, that is now x squared. And hopefully at this point, you remember that if you are trying to solve and you have a second power, that's a quadratic. You need to get everything on the same side. And in this case, we want it on the right because we want the x squared to be positive. So whether you write this on both sides or you just move them over, what you should find when it's equal to 0 is that now the 2x is positive and the 15 is negative. If the 15 were positive, we would not be able to factor because the signs would have to be the same. And then you could use quadratic formula, but why? Please factor. So what two numbers multiply to be 15? Negative 15, but when we add them together, we get 2. Or you might think when you subtract them, you get 2. 5 and 3. 5 goes with the plus since it's a plus 2. 3 is with the negative. We are almost finished, but we are not. So then when I solve each of these, this would be x is negative 5 and x is positive 3. And then I should check them. You could check it after you got the radical by itself or even in the original. If I put it in the original, 15 minus 2 times negative 5, that would be 25. Plus 5 times negative 5 is negative 25. And 5 times negative 6 is negative 30. But this would be a 5. And 5 minus 25 is negative 20, not negative 30. Also, if I just went back to this part, when the radical was by itself, it's equal to x. It's not going to be equal to a negative. No. So he's extraneous. This answer should be the only answer that remains. There are times that the x could be negative, but there would have to be something else on the right side at the beginning. All right, so that was our first lesson from Tuesday. Now, we didn't do a whole lot of practice with this because what was in our packet combined a lot of rules together. What I need you to know is to go from the exponents to the radical form. And then for ones that are very obvious, we should simplify. So I'm going to give you examples that will be similar to what I would give you. So the whole thing is in parentheses, so that means that exponent applies to the whole thing. The bottom number of the fraction exponent is the index, and the top number is the power. So you could give me that. Those mean the same thing. It would not be the same if you just write 15x squared and the 15x is not in parentheses. That does not mean the same thing. In number 5, We have 25x squared to the 1/2 power. So 1/2 power, remember if I don't see a number, it's like that's a 2. And 1 just means like it's just itself. But can we take the square root of 25? Yeah, so we should go ahead and do square root of 25 is 5. And what is the square root of x squared? X. So 5x. So this one should be simplified because it doesn't have anything left under a radical.
What if you give it like that?
Like what?
Just 25.
If you give me this, you'll get partial credit, but not full credit. Okay? That's what'll happen. Now we're going to go the opposite direction for 6 and 7. They start out with radicals, and we will be rewriting them with exponents. So this is x to what power? Somebody help me. 2 over 3. The exponent goes on the top of the fraction exponent, and the root, the index, goes on the bottom. And then here, what is the root? First, what is the index if you don't see an index? 2. The index is that little number inside. That would be a 2. The exponent on the x starts out as being a 1. So this would be x to the 1/2, y to the 3/2. The 3 does not apply to the x. The 3 is only applying to the y. Oh, goodness. So here I have put them kind of in the middle so that when you have to factor, you have space to factor above and below. So if you're wondering why the problems are kind of seem like they're in the middle of the page, that's why. So for number 8, we are not factoring. We are just using our exponent rules. So the 25 over 40, I got to make this bigger. The 25 over 40, we just want to reduce. And remember that those big numbers don't behave like exponents. So please, if you wrote down 15, erase it. So there's no 15. Hopefully no one did that, but if you did, erase it while I'm getting my stuff together here. Okay, maybe that's a little better. Until I click this button, then it gets a little smaller again. All right, so 25 over 40 reduces. We can divide them both by 5. So that becomes 5 over 8. Where is there the higher power of x, top or bottom? Bottom. So the x's are going to live in the bottom. How many extra does he have? 2. So basically, from the big number to the small, 5 minus 3 is 2. What happens with the y's? They're gone because it was both the same. So there is no y in the answer. It is important that I can clearly tell that your x squared is in the bottom, not just kind of out to the side. And then number 9, now we start factoring. So we factored the top. So I see a trinomial, so this means my factor sheet might be helpful. So 2 sets of parentheses. They both have an x. I have 12, positive 12, so the signs are the same, and they add up to positive 7. So both positive. What two numbers multiply to 12 and add to 7? 4 and 3, 3 and 4, in whichever order you want to list them. What about the denominator?
4.
4 and 4. And what about the signs? Yeah, 1 plus and 1 minus, right? Because the middle cancels out. That was a difference of squares. And then we look to see, can we cancel a common factor? Do we have a common factor? X plus 4. So those entire parentheses are gone. And then our final answer is our x plus 3 over x minus 4. Right. If you had already figured that one out, give yourself a big pat on the back. Give your neighbor a high five. Good job. So, lots of factoring in the upcoming problems. When I taught Algebra 1B and I had people factor probably hundreds of problems, they thanked me when they got to Algebra 2 because factoring was kind of automatic then. All right, now we are to multiply these rational expressions, which means lots of factoring. We need to factor all 4 places, and then we can cancel as long as it's a top and a bottom. It could be in the same fraction or in different, but it has to be something on the top and something on the bottom. 2 things on the bottom do not cancel each other. So let's start with that top left. How could that factor? Oh, come on. Sorry, pause this. It's not the time there, buddy. All right, and we're back. So someone told me x plus 5 and x minus 5, or at least I hope someone said that. I think so. What about so that was this one. What about our top right? X squared plus 5x minus 14. X and plus 7. And what was the other one? Negative 2. Good. And remember the plus has to be with the 7 there so that when you add them together you get positive 5. Good. How about this denominator on the left? Bless you. 3 is greatest common factor. Please do yourself a favor and do that first. Also, if you try to go straight to asterisk, you will lose the common factor. So we need to take out the common factor. And then we have we have x squared plus 3x minus 10. And could that factor more? Yes. Now, the trinomial that we're left with, what multiplies to 10 and subtracts to be 3? Negative 2 and positive 5. Bravo. So this has now been replaced with what's below it. You don't necessarily have to mark it out, but you don't want to use both of them. And then we have one piece of the puzzle left. What is going to happen with the 6x minus 30? Just common factor. And what is the greatest common factor for those two? 6. Good. And then we have x minus 5. And then at this point, we have the I feel like it's just kind of satisfying. Like when I see, oh, look, this one. Remember that each one can only cancel one thing in the other part, although in this case, there's not anything that you would be tempted to overdo. So now I'm going to start canceling things. I just usually start at the top left. I see x plus 5 and an x plus 5 in the bottom. Then I have an x minus 5. Do I have an x minus 5 in the bottom? Yeah, so they are gone also. I have an x plus 7. Do I have an x plus 7 in the bottom? No, so he stays. I have an x minus 2. Do I have an x minus 2 in the bottom? Yes. So notice how I kind of went systematically from left to right because you don't want to leave something out. Everything that's not crossed out is part of our answer. So we have x plus 7 in the top. Since he's the only thing in the top, we could put parentheses, but it's okay to not. And then on the bottom, what do we have left? 3 and 6. Remember, this is a multiplication problem, so we do 3 times 6 is 18. Done. Bravo. So lots of factoring. Then you're just going through and canceling out your factors. What changes with division? How is division different than the multiplication? Yes, the second one, reciprocal, or it gets inverted, it gets flipped. So the second one only is going to switch. So I usually do it when I do my factoring, but just to be, I didn't leave myself any space up top. Oh, I got to move my screen so I have space up top. Oh, come on. There we go. So the second one only flips. So if I change this to multiply and I write this one on the top and this one on the bottom. Now, if you do that right next to it like I just did, then I would be sure to get rid of this. Don't look back at it. Or you could, as you factor it, when you factor the top, move it to the bottom. So I'm just going to rewrite that part here to make sure that I don't forget to flip it over. Can 4x minus 3, starting here, can that be factored? No, right? So got a little bit easier route there. What about the guy below him? What about our 4x squared minus 7x plus 3? Can that be factored? Maybe, right? There is not a common factor, so this is where I personally would use asterisk. Some of you might use a different method, but this is where we would do 4 times 3 is 12. Don't forget that there's a 4x on each side. What multiplies to be positive 12 and adds up to be negative 7? Right, 3 and 4, both negative signs. Both negative signs. They have to be the same sign to add or to multiply to be a positive. Also, if they were different signs, they wouldn't add to be negative 7. Then to do our factors from there, I have 4x minus 3. And then don't forget that the other one reduces to be x minus 1. Remember that if you multiply this out, it has to be this. If you leave a 4x here, it's going to be 16x squared, and that's not what we have. So the left side's been factored. Now the rational expression on the right. Let's go to the top right. It's a trinomial again. So what multiplies to be 3 and adds up to be 4? 3 and 1. And what about the denominator? 16x. Yeah, remember we want to go as big as possible. Bless you. In this case, you could check your factor sheet. 16 is a factor of 48. So 16x is their greatest common factor. And then we would be left with x plus 3. And now everything is factored. So now we would start scratching things off. So over here on the left, the 4x minus 3 and a 4x minus 3. It can be the same fraction. Now when I move across, do I have an x plus 3 in the bottom? Yeah, so cancel, cancel. Do I have an x plus 1 in the bottom? Do I? No, I don't. I have an x minus 1. I can't. And don't just go like, oh, well, I bet this is supposed to be plus 1. No, that would not make this factoring work. So at this point, then that's all we can cancel. The top still has x plus 1. The bottom, when it has something like a common factor, you will typically see, it would be the same, but you'll usually see it written this way. The x minus 1 does have to live inside parentheses. I could write it this way. You don't usually see it that way, but do not leave out the parentheses. Since something else is down here with this, whether you write it first or second, it does need the parentheses around the x minus 1. In the top, if you want to put parentheses around the x plus 1, you can, but since he's the only factor up there, we don't have to. Three more. Now we're going to go to adding and subtract. Actually, 4 more. Sorry, didn't mean to mislead you. 4 more. Now we're going to adding and subtracting. And remember, for adding and subtracting, just like fractions with only numbers, the denominators, D for down denominator, the bottom of the fraction has to be the same before you can add them together. So if the bottom is the same, your life is pretty easy. So if the bottom is the same, which here it is, and then I just add the tops together, 5x and 3x, 8x. And then you do write 2x plus 1. And then it's done. Please don't try to get squirrely on me. I mean, there are times it could simplify, but this is not one of them. And then what about in 13 when the bottom is not the same? This is when they look at each other and they want to have the same thing. So when the fraction at the left looks to the right, he says, hey, he has x plus 4. I need an x plus 4. So we give him an x plus 4, but that means his top also gets an x plus 4. And the guy on the right says, hey, wait a minute. I need an x plus 2 so that I look like you. We are going to need to make the same denominator. I was recording, and at some point something didn't get recorded because it had stopped. But que sera, I guess, be at school, right? So what do I need to multiply the left fraction by? X. So it can be very tempting to think, why x? He already has an x. But what he has is an x plus 3. He doesn't have just a plain x. He needs just a plain x that's not having 3 added to it. And on the right side, he doesn't just need, we can't just do plus 3. He needs that whole x plus 3. Like if we knew x was 5, then x plus 3 is 8. So like you're multiplying, not adding. So you got to do that whole set. And whatever we do, their denominator needs, we also have to multiply that times the numerator. So now on the top, what is x times x? Because remember, this is multiplying. What is x times x? X squared, right? X to the second power. Now, do yourself a favor. Think of this as being -4. Or if you want, you could change this to say plus and then put the minus up there so you don't forget. But -4, go ahead and distribute with -4. -4 times x, -4x. -4 times 3, -12. And then the bottom, leave the bottom in factored form just in case the top factors and we could simplify. In this case, does the top factor? It could factor, right? X minus 6, x plus 2. But as it turns out, does that help? No. So I would want to try this, but when I factor this, it doesn't match these. So this answer is acceptable, or if you have done this and you want to give me this answer, either answer is okay. But remember that if one of these matched this, we would cancel it out. So even if what you give as your answer is what I put in the box, you should have thought through the factoring to make sure that you can't cancel a common factor to simplify. All right, the quiz, of course, is very similar. Different questions, of course.